Alright, what's up guys? In this video I'm going to put some calculus here. It's going to be integration practice video number 22 that we're going to work on. Alright, so we need to evaluate this integral here. We got the antiderivative, the square root of 9 minus x squared, all divided by x squared, integrated with respect to x. Alright, so this is a trig substitution. And we can clearly see that we have the square root of a squared minus x squared. So in that case, this is a sine substitution. So x is equal to a sine theta. All right, so notice our a here is 9. If I take the square root of that, I'll get 3. So therefore, x is going to be equal to 3 sine theta. Now, you need to take the derivative of that. That'll give me 3 cosine theta d theta. Alright, well, then we'll just take our integral and plug everything in. So we get the square root of 9 minus, we'll stick our x in there, which is 3 sine theta. Don't forget that's going to be squared. That's going to be divided by 3 sine theta squared. And we'll multiply it by 3 cosine theta d theta. Alright, let's clean it up a little bit. I always go through and clean up everything in small incremental steps. I don't skip any steps in my videos because if I'm skipping steps, then I'm not really helping you. So I don't skip any steps. I always go through all the steps because that's what you come to see. You come to see the answers. So we get 9 minus 9 sine squared theta because we're squaring not only the 3 but also the sine. And if we factor out a square root of 9, we'll simply get 3 times the square root of 1 minus sine squared theta, which we know is just cosine squared theta. So then this just becomes 3 times cosine theta when we take care of our square root. Okay, so now what we got is our integral, and then essentially what we'll have at this point is just 3 cosine theta. Down here at the bottom, we'll have 9 sine squared theta. And we're multiplying that by 3 cosine of theta d theta. And this just simplifies down to the integral cosine squared theta over sine squared theta d theta. Now remember that cosine theta over sine theta, remember that that is cotangent theta. Okay, why do we know that? Well, remember that sine over cosine is tangent, so if sine over cosine is tangent, then the reciprocal of that would be cosine over sine, which is cotangent. Now in our case, we got cosine squared theta over sine squared theta, so we could still use it, except it'll be different. So cosine squared theta over sine squared theta, if you remember from trigonometry, that's just, in our case, it's going to be cotangent squared theta. So that's what the integral will become at this point. Now, we can't easily integrate cotangent squared theta just right off the top of our head, so we can break it up using a Pythagorean identity and simply write it as cosecant squared theta minus 1 integrated with respect to theta. Okay, so now we go through and integrate it. So remember that the antiderivative of cosecant squared theta, that's negative cotangent theta. If I integrate negative 1 with respect to theta, I get minus theta, and then I add a plus c. Okay, so the next thing that we do for the trig substitution, remember we need to find negative cotangent theta. So this is where the trigonometry comes in. So remember that for our substitution, that x was equal to 3 sine theta. So that means that sine theta is equal to x over 3. Now, if you remember from trigonometry, the SOHCAHTOA, so SOHCAHTOA, we need to use that for sine to figure out what the opposite side and the hypotenuse is. So in the case of sine, since we know a sine is opposite over hypotenuse, then that means that this x here would be our opposite side and the 3 here would be the hypotenuse. Now in our case, when we continue, we now need it for cotangent. So again, if we go back to SOHCAHTOA, so if we look at SOHCAHTOA, remember that tangent is opposite over adjacent. Cotangent is the reciprocal of that. So since tangent is opposite over adjacent, then that means that cotangent will be adjacent over opposite. So we'll have cotangent theta, I should say, is adjacent over opposite. All right, so then we just use Pythagorean theorem to find the missing side. So we already got the opposite side and we got the hypotenuse. So we'll simply have x squared plus b squared. We're missing the adjacent side. That's the side we got to find. And then remember that the hypotenuse was 3. So if I square that, I'll get 9. So we'll get 9. Subtract x squared from both sides. You'll get b squared is equal to 9 minus x squared. Take the square root of both sides, and I'll get b is equal to the square root of 9 minus x squared. So that's the adjacent side. So if we draw a triangle, we can actually see what I'm talking about. And again, you don't have to draw the triangle, but it does help a little. So we got our angle theta. Remember, the hypotenuse is the longest side of the triangle, or the side of the triangle that's directly across from the right angle. And we know that that's just 3. The opposite side was x, and the adjacent side, which we just recently found, was the square root of 9 minus x squared. Now, the reason why we have to do that is because, again, we need cotangent theta. We needed the ratio of that. And since cotangent theta is adjacent over opposite, well, we didn't have the adjacent side to start with, so that's why we have to find it. So now, cotangent theta, in our particular case, is just simply going to be the square root of 9 minus x squared all over my opposite side, which is x. Now, if we go back to our substitution again, go back and remember that sine theta was equal to x over 3. Now, much like for a u substitution, you got to convert back to the original variable. So that means that theta, that's arc sine, or sine to the negative first of x over 3. So we can easily now just write our final answer down. So final answer here, we're asked to integrate the square root of 9 minus x squared all over x squared dx. So our final answer for this integral is going to be negative square root of 9 minus x squared all over x. And this would be subtract arc sine, or sine to the negative first, of x over 3, and then we do have to add the plus c because it's an indefinite integral, and that's the answer. And that's your solution. Alright, so I got plenty of videos on trig substitution. So if you're still struggling with trig substitution, please check out my YouTube channel. I got plenty of examples on trig substitution on there for you to look at. Trig substitution is very important, and it's really one of the, I love doing trig substitution. It's a very, very, very fun process. I do a trig substitution over integration by parts, or even though I know how to do integration by parts, I tend to like the trig substitutions a lot better, and I definitely do a trig substitution over partial fractions. Even though I know how to do partial fractions, I would prefer to do trig substitution because it's a little easier to me. So let me know if you got any questions, and we could talk about it. So we'll see you next time.